Alright guys, so today we're looking at double angle formulas. So in purple above, those are the double angle formulas for this chapter. We have a sine of 2 theta, 3 cosine of 2 thetas, and then a tangent of 2 theta. One thing I do want to point out is a lot of people have gotten this confused in the past. Make sure you're aware of the difference between this and that. So the sine of 2a versus sine squared of a. So remember, the sine squared of a is like you're squaring the whole term. Sine of 2a means you're doubling that angle measure. It's easy if you're not paying attention to get the two of those confused. Basically, in this chapter, we're doing the exact same thing as before. The only difference is just new equations, same concepts. So first, let's start with drawing our triangle. It says our triangle is our a is in between 3 pi over 2 and 2 pi, which means in radians it's down here. So we're going to mark that as a. Okay. And then let's see, it says -4 fifths, so that is 3. Let's go through and we'll just plug stuff into the equation. So we want to find the sine of 2a. That's 2 times the sine of angle A times the cosine of A. So we look at our triangle, we're going to have 2 times the sine of A, which is -4 over 5. And then the cosine, which is 3 over 5. Multiply them all together, you get -24 over 25. Alright, so then let's look at the cosine. I do realize there's 3 equations, and honestly, I don't know why there's 3 of them. But what I do is I try to pick the one that best fits what I have. So like in this instance, it doesn't really matter, except I'm given sine of A, right? So I would probably want to use the one that only has a sine of A in it, because then there's no way I'm getting the values mixed up on accident, things of that nature. So I'm going to use 1 minus 2 times the sine of A squared, which would be -4/5 squared. So I'm using this middle equation right there. So I square 4/5 to start. Remember, when you square a fraction, then you have to square the top and the bottom. Okay. So then multiply by 2, so I get 1 minus 32 over 25. And I have to subtract that. I have to get a common denominator, so 25 over 25 minus 32 over 25, which should give me -7 over 25. That is, oops, that's a -7. I kind of screwed that up there. Okay. So, that's the basics right there. Alright, now you're given a cotangent that is -1/4 and secant of theta is less than 0. So what we have to do is we have to figure out where our picture should go. So we know cotangent is negative in 2 and 4 from all students take calculus. Secant and cosine are negative in 2 and 3. So our picture is going to be in quadrant 2. It's the only one where both work. So cotangent is -1/4, so that's -1/4 because it's adjacent over opposite. We have to do the Pythagorean theorem, so 16 plus 1 is 17, so the hypotenuse is root 17. Not the nicest of numbers, but it'll work. Okay, so let's go back. Cosine of 2 theta, it doesn't really matter what equation we use. I really generally wouldn't use this third one because it involves finding 2 different answers, but why don't we can use this second one. So we're going to go 2 cosine squared minus 1. So let's go 2 times the cosine squared, so cosine would be -1 over root 17 squared minus 1. One trick here, I would not rationalize that value because when you square it, you're going to get rid of that radical anyway, so rationalizing it just actually makes it harder. So here, if I don't rationalize, I have 2 times that squared, which is just 1 over 17, minus 1. So I have 2 over 17 minus 1, which would equal 2 over 17 minus 17 over 17. So you get negative 15 over 17. Alright, now a sine. 2 sine, cosine. Unfortunately, there's no options other than that one. So I'm going to take a 2. I'll multiply that by the sine, which is 4 over 17, or 4 over root 17. And then the cosine, which is negative 1 over root 17. And again, in this instance, I wouldn't rationalize until later, because here, root 17 and root 17 are going to multiply, and they're going to become 17. So again, if I would rationalize, it would cause me a bunch of extra work. So when I multiply it all together, I get negative 8 over root 17. Oops, no root. I just said that, and I still messed it up. Negative 8 over 17. No more simplifying to be done, so that's my answer. Alright, so lastly here, we want to simplify and evaluate exactly if possible. So this is a double angle, obviously, you can tell it's tangent. So this here, this is actually going to equal the tangent of 2 times whatever angle measure is here, and you can see it's pi over 8. 2 times pi over 8 would be tangent pi over 4, which you should have memorized by now as a 1. And then our proof. Okay. Well, let's see what we got here. So we're going to work this right-hand side. So we need to use a cosine formula that has a sine squared in it, because we're trying to get a sine squared. We're replacing that. So we're going to use that. So we have 1 minus 2 sine squared version over 2. Alright. So then distribute the negative. 1 minus 1 minus 2 sine squared. 1 minus 1 plus 2 sine squared theta, which over 2, those cancel, leaves you with a sine 2 or sine squared of theta. Alright, that's it. Hope it makes sense, and we'll keep moving on. Have a good one.